Hello, I'm Andy, and in this talk I'm going to look at using the RS-232 protocol to send bytes of data back and forth from the NX controller to a PC. Now, RS-232 is a point-to-point protocol and it provides a send and receive line between just two devices. On this image we have an overview of the hardware I'll be using. On the left we have the controller. This could also be an NJ controller as well as an NX, as all these Omron controllers support EtherCAT and the function blocks we'll be using. I'm showing the wiring used as my PC, like most modern laptops, doesn't have an RS-232 port. I'm using the Omron CS1W CIF31 adapter to provide the RS-232 port. In practice, often the devices connected to the NX controller will be something more like a barcode reader or a weigh scale on the factory floor, but here I'm using free third-party emulation software, the Hercules one, that allows us to easily see the data received and allows us to create data to send. Older Windows operating systems used to offer a terminal program called Hyperterminal. Hercules and the other one, Termite, do a very similar job. This image is mainly for reference, so please rewind, pause and screenshot as you need to. It shows the communication settings made on the serial tab of the Hercules software and how they must match the settings for the system you have. On the left are the Sysmac Studio settings and on the right are the windows needed on the PC side. For my setup, I need to know what port number was allocated when I plugged in the CS1W CIF31 adapter. Here's one way you can find it. So bring up your device manager, look under ports. There you'll find where I've highlighted the COM4, so port 4 has been allocated. Now we set up the Hercules software to provide our emulation. Double click Hercules to get it to run. It's an exe file. Select the serial tab. Check the setting of those that we want. Parity, data size, etc. And finally open the port with the green map. Moving on to Sysmac Studio now. Here we have it online and we have the settings area for the communications card that we're using, and this is found from the configuration tree on the Project Explorer inside Sysmac Studio. And here we can see in purple the settings being made to match up with our configuration. Here we have the number of characters to determine the end of this set of bytes being sent. There's always a help, some information here. So we send the settings we want down to the unit. That was completed, and we have a compare function to see what settings are actually on the current unit. As with other Omron interface cards, the IO mapper is automatically prepared for us, and in my example I will need just two variables. First, I have to display node location information by right clicking on the CIF item, and I'm not going to use the auto completion. I'm going to type my own name in for the node, and also I need to, in my example, with using the function blocks that are provided, we'll come to later. I'm going to use a flag called receive data exist. Now I have both Sysmac and Hercules software open and am ready to test using this pre-prepared program. The sending program, as you can see on the screen now, needs only 4 rungs and uses the 2 functions or function blocks, NX serial buff clear and the NX serial send function block. With these 2 functions, we can simply prepare an array of bytes to send. On rung 2, in this example, we're adding ASCII characters to the end of a 31 byte array that we send to the Hercules program. On rung 1, I am converting some strings or text data to ASCII bytes for my array being sent. Typically, the format required is defined in a document for the device if it's a barcode reader or grayscale. And on the screen, you can see the results in the watch table and on the Hercules monitor window. There are some settings in Hercules available, including a clear window with a right click in that window there. Or you just carry on with that testing. It all looks okay. Now if we shift from the sending to the receiving section of the program, we're going to use the NX serial RCV or receive function block. So with that, we have to go to the Hercules terminal window now and choose what to send. Hercules will allow you to send either hex or, as I'm doing, text characters that in the background will be converted. If you want to work directly with hex, there are some tool tips you can find by right-clicking in the Hercules windows, and it will tell you the syntax. So here on the watch window, you can see the results of what we're receiving. I'm using the Windows clipboard to cut and paste messages in. It's a nice feature, which means you can pre-prepare messages, maybe save them on Notepad or something. You can see the amount of bytes we receive reported by the function block. So if I send those 10 bytes, you can see the received size has changed to 10, and we're not missing any there. Now it's back to 40. Now if we go over and take a closer look at the watch window, you can see a useful feature. You can arrange the watch window to display all the elements of the array, and you can, on the right hand column, select how you wish that data to be displayed. By the combo box, you can choose to display it as ASCII, and you can see the online value is changed for you. Worth mentioning, there is a monitor built into Sysmac Studio for the serial card. You can find this monitor that we see now by going onto the card itself. With the right click, you'll be able to select the CIF serial line monitor, which I already have open, and you'll be able to start monitoring according to your monitor selection up here. So if I was to start monitoring, you can see the monitor is now running, and if I start sending some data, send this a few times, you can stop monitoring, read the monitor data. I don't want to save it to a file, I just want to take a quick look to see what was going on. You can see some statistics, and yeah, here's the data. 456, 456, 456. These will be the ASCII characters 4, 5, and 6. So I hope you may find that brief introduction to using the CIF RS232 port within Sysmac useful, and thanks for listening.